In this presentation, we explore how Google Generative AI Gemini can significantly enhance the legal context domain. We are Amadeo Paquera and Gianluca Rossi, and I'm here to present LawLang. So this is the outline of our presentation. We know that drafting and validating legal contracts is high complexity task that traditionally requires deep legal expertise even for standard agreements. Not only the language must be precise and legally sound, but each contract also needs to be thoroughly checked against applicable rules and regulations to ensure compliance. For small and medium-sized businesses, accessing custom legal support is prohibitively expensive. The process is also time-consuming, often diverting critical resources away from core business operation. Without expert guidance, contracts may include unclear terms, legal gaps, or costly errors that expose companies to significant risk. These challenges are also further amplified when operating across borders. Different countries have their own legal system, standards, and regulatory requirements. For a contract to be enforceable abroad, it must be accurately adapted to local laws. Navigating these international legal frameworks typically requires specialized and expensive legal advice. One of the most difficult aspects is contract transposition between countries. Translating legal intent and structure from one jurisdiction to another one without losing meaning and enforceability. Legal concepts may not have a direct equivalence across legal systems, making the process error-prone and highly specialized. As organizations scale or expand into new markets, the volume and complexity of contracts grow rapidly, compounding all of these challenges. This is where Gemini, Google's powerful generative AI tool, comes in. By leveraging its advanced language capabilities, we can streamline the contract drafting, review, and localization process. Gemini enables us to generate and adapt legal documents quickly and cost-effectively, while maintaining alignment with jurisdiction-specific regulation. Our goal here is to demonstrate how generative AI can reduce costs, mitigate legal risk, and support growth in the increasingly globalization business landscape.
We developed LawLang, a system that allows question answering about different codes and laws. So it replies specific question about laws and codes, but also comparison between different jurisdictions. Then it allows to perform compliance checking over contracts. So verifying if a contract is compliant with a given laws or a given code. And then it allows international translations. So given a contract, it translates from a language to another, but also from the rules of a specific jurisdiction to the laws of the different jurisdiction. The design of LawLang, I will now present the pipeline. In input, we have a set of articles from a given law. For each of these articles, we extract embedding vectors, and together with this vector, we extract a set of rules that this article describes, and a set of concepts that we use to build a knowledge graph of this given code. Then, we do the exact same thing with a code from a different jurisdiction, so for example, a different country. We extract the embeddings, the set of rules, and we build the knowledge graph. And then we leverage these two embeddings to build an agent-based question answering chatbot that is able to answer questions about specific laws, but also comparison. After that, we do graph alignment. So we leverage graph alignment techniques to align these two knowledge graphs that allows us to be able to retrieve concepts from different laws. Then the user input a new contract and we tag this contract with the concepts given a knowledge graph in input. And also we can apply rules to verify that this contract is compliant with the given code. After that, we can leverage these tags that comes from the knowledge graph to perform a translation of this contract, both linguistic but also compliance based. So we verify if this contract satisfies the rules given by the second jurisdiction. For this specific project, we used the Uniform Commercial Code, that is the commercial code from the United States, the German commercial code and the dataset contract NLI, from which we extract some samples of contracts to test our implementation. Specifically, we focused on the article 2 of the UCC, that is the one that describes contracts about selling goods, and articles from 350 to 384 from the German Commercial Code, that are the correspondent articles that describe the contract about selling goods. And for what concerns the first part of the pipeline, so the extraction from the given code, we used techniques like embedding, few-shot prompting, LLM-powered evaluation. This first function is used to extract embeddings from each article of the laws using the text embedding 004 model from library. Then we designed this few-shot prompt to extract a set of concepts and rules for each article of the law. And in this example, you can see that we gave to the LLM 2 examples with the expected output. And of course, this was controlled using a structured output configuration for the LLM. Finally, we use another LLM, a second LLM, to perform evaluation on the output from the first LLM. This second prompt is used to ask the model to assign a score from 1 to 5 of the extracted concepts and rules given an article. Then we use the output of this evaluation to filter the extracted rules, and we keep only rules with score 4 or 5. The agent-based Q&A chatbot, we used techniques like embeddings, retrieval augmented generation, and agent with tools using LangGraph. So first we defined these three tools. These three tools are RAG-based, so they use a retrieval augmented generation approach. Taking, for example, the first one, it used this find top laws function. That is a function that, given a question, creates the embedding of this question, and then use the dot product to find the most similar vector in the embedding space of the articles. So it retrieves the top 3 laws, and then it uses the generate answer, that is an helper function, to create the answer using, of course, another large language model. The second one is the tool for the German law. In this case, we first translate the user question to German, and then we look in the embedding space for the German law to find the most relevant laws before generating the answers. Finally, the final tool combines both previous tools, and it's used to perform a comparison between the two laws. And this is the function that generates the answer given in input the laws retrieved from the embedding space. Finally, we define the nodes of the Lang graph, one node for each tool, and then we combine this node into our graph. This is the chatbot in action. Here we are asking about the division of risk in the US law, and this is the output that it generates. While if we change the question asking to compare the division of risk in the Germany and US law, this is what we obtain. So a detailed description and a comparison between the two laws.
Here we show how we can align two different regulation systems. Here are the techniques employed: the embeddings, zero-shot prompting, and semantic search. So what we do for each input legislation system, we create a graph and ontology by using the RDF library, And from the input legal framework, we extract laws, article, and concept. Here there are the results. On the left side, we have the legislation system in the US. And on the right side, we have the German one. And what we do is the following pipeline. So, step one, we loop each US law. Then we embed this US law with an embedding function. Then we translate this law to the German one with Google Generative AI. Then we take the embedding of the translated law and we find the closest law in the German by using the dot product. So we combine the laws with the tutor system, which have the smallest distance in terms of semantics. And once we have found the closest one, we create the alignment in the two laws. And here are the results of this approach. So here we describe how to tag a document. So we use a Sparkle query to extract the concept present in the input document. And then we use this prompt with the zero-shot technique to ask Google Generative AI to extract the classes with which tag a clause of the input document. We then use another prompt with the few-shot approach to check that the contact adheres to the specified rules. And if a rule is not satisfied, we use another LLM with zero-shot prompting to make a suggestion on how to fix the broken rule. Here we have an example. We have in input a contact from the dataset contact NLI. With this function, we extract the classes, and then we tag the input document. And then we have the final results. And here we see that for each clauses, we have the GG classes extracted and the list of rules.
Consists of the translation of a contract from a language and so a jurisdiction to another language and so a different jurisdiction. And at this point, the techniques are just a collection of what we have already seen, except for this function that performs a Sparkle query over the aligned knowledge graphs and allows us to retrieve concepts from a different jurisdiction that are mapped in the one that are used to tag the user input contract. When we retrieve then this concept, this is the loop of translation of the contract. We first translate each clause to German, and then we use this function to retrieve all the concepts that are mapped in the German code, in our case. And with these concepts, we retrieve also the articles and the extracted rules from that article. And then, of course, we can apply again the verification of this rule as previously shown. Translation in action. So that I described performing the Sparkle query. This is our element, the contract, from the contract NLI dataset. And here we apply the function that extracts and translates the clauses into German and extracts the German concepts. So here you can see an example of output with all the rules related to the German jurisdiction. Then we apply the verification, and of course we can concatenate each clause after the verification to obtain the final contract in German. So to conclude, we presented LawLang, our system that showcased the power of generative AI in the law domain, and we presented different tasks. So we showed that using generative AI we can perform question answering about laws and different codes, but also compares the two different jurisdictions. Then we can process and structure, so extract information from this contract and build knowledge graphs to organize and giving a structure to this contract. This allows us to perform rules checking, but also to do translation from a jurisdiction to another. This is very powerful because, of course, in the future, it allows different extensions because we can include different corpuses. So at first we can including all the articles from the two codes, but of course we can include also laws from different countries, so combine them together and adding all the alignment between all possible laws. Of course, this can include a human-in-the-loop approach to refine the extracted concepts and also rules. So we can design a human AI teaming approach with legal experts in order to obtain an accurate extraction of concepts and tagging of different contracts. And expanding the scope, of course, brings a scalability problem, but for that reason we can include the use of graph neural networks that are useful when we are dealing with large graphs, and they can be applied in different manners. We can use the embeddings extracted from each articles as features for nodes, and then we can train this graph neural network to infer implicit relationships, but also detect inconsistencies among different knowledge graphs. And one of the recent and novel approach are the graph retrieval augmented generation. So the RAG approach applied to graphs, and we can leverage this approach to perform a novel question answering techniques that combines both the power of graphs and the power of generative AI. Thanks for the attention, and in the description of this video you can find the link to our detailed article and to our notebook with the implementation codes for LawLang, and together with our LinkedIn profiles. So if you have questions, you are free to contact us and ask us questions. Thanks for the attention.